Hello, y'all, and welcome back to my DP chemistry curriculum. Today we're going over structure 1.3.3 for my lesson 9. We're going to be talking about the main energy level. It's given its integer number n and can hold a maximum of 2 to n to the squared electrons. Something we'll be able to do by the end of this lesson is deduce the maximum number of electrons that can occupy each energy level. We'll also learn the shape of the sublevels for S and P, or sorry, the orbitals for S and P sublevels. So without further ado, let's begin. Now, as we talk about main energy levels and sublevels, we're basically talking about where the electron is, so electron location. Now, Bohr said they were in discrete energy levels. But the problem with them is they're so small and they have such little mass that we actually cannot know both their location and velocity with certainty. And that was discovered by this guy named Heisenberg. You might have heard of the Heisenberg uncertainty principle. So the Heisenberg uncertainty principle says we just can't know where these little electrons are going. We can't know how fast they are and their exact location, but that's okay because what we can do is we can kind of like assign a region where an electron is likely to be. So they'll be there most of the time. We call this region an orbital. Sometimes we might just in front of it say an atomic orbital. So that's kind of what we're going to be dealing with today. We're going to be dealing with atomic orbitals as we move from main energy levels to our sublevels. So going back to our lesson, our previous lesson, lesson 8, our main energy levels have a numerical assignment. Energy level have a numerical assignment. We generally refer to them as n equals 1, 2, 3, and we actually go up to 7. We'll talk about why that's important, but as far as we know, we can only have atoms with up to 7 energy levels. Now, within each main energy level, there are also sublevels. So within n equals 1, there's a sublevel, n equals 2, there's more, so on and so forth. These sublevels are assigned with the letter, assigned a letter. And those letters are going to be S, P, D, and F. So one of the questions is how do we get those letters? And these are based on the shape of the orbital, based on the shape of the atomic orbital. For the DP chemistry curriculum, you only need to know two shapes, and that's going to be for our S and P orbitals. You do not need to know the other ones. They get very complex and very weird. So let's start with the S orbital. The S orbital is really simple. It is a sphere. So the S orbital in the first energy level is a sphere. The S orbital in the second energy level is a bigger sphere. Third energy level, a bigger sphere. So S orbitals are the simplest and also the lowest energy orbitals of the sublevels. Next, we move on to our p orbitals. The thing about p orbitals you'll notice is they're a little different. First off, there's going to be three of them per energy level. While the S only has one, P tends to have three. And we need a little bit of an X, Y, Z axis for this. And because there are three, I'm just going to do three examples, and it looks like I have made them too large. Gotta grab that X in there. So we have three orbitals, and these look a little different. I'll switch colors here. So we have one on the x-axis, and this is, of course, three-dimensional. It's not just a figure eight. We have one on the y-axis, again, also three-dimensional, and one on the z-axis, also three-dimensional. This is our px, our py, and our pz sorry, px, py, and pz atomic orbitals. And these we generally call dumbbell shaped. So these are the shapes that you do need to know of the orbitals. One other thing about these orbitals is each orbital holds two electrons. So that means for the S, we could have two electrons, and each P could have two electrons. So that means for X, Y, and Z altogether, the p orbitals hold six electrons, or the p sublevel would hold six electrons. 2 plus 2 plus 2. All right. So there's a little chart we can make to kind of keep track of this. So over here we have our energy level, N. Then we have our sublevel. And I'm just going to get ahead of myself and try and give myself a line to follow. We can do our number of s orbitals, our number of p orbitals, our number of d orbitals, our number of f orbitals, our total number of orbitals, and our total number of electrons. Waiting for that to snap to the grid. There we go. Feel like there should be an easier way to do this, but gives you time to keep up without having to pause the video. Just makes the video a little longer. Granted, of course, in these times, I could always just pause it and come back. All right. So, in the first energy level, turns out we only have the one s sublevel, which means we have one s orbital, no p, no d, no f's. So we have a total of one orbital and a total of two electrons. In the second energy level, we have a 2s, but we also have two p sublevels. So we don't get p sublevels until we get to the second energy level. In that case, we have one s orbital still. We have three p orbitals, turns out. We have 0d, 0f, so we have a total of four orbitals and eight electrons. In the third energy level, we have our, whoops, not 2s, we have our 3s, our 3p, and our 3d. So over here we still have 1s, we still have 3p, but it turns out there are 5d orbitals. Not three, not one, but five distinct d orbitals, which brings us to a total of nine orbitals, holding a total of 18 electrons. And lastly, we have our fourth energy level. And we could go further down, but we're only covering up to four. Here we have our 4s, our 4p, our 4d, and our 4f. So we have 1, 3, 5, and there are 7 f orbitals. And so for our total number of orbitals, we have 16 for a total of 32 electrons. So when we look at each energy level, we can predict the total number of electrons it could carry by just looking at each amount of orbital. So we have a different amount for each energy level. As we described in our standards earlier, that you can just use the equation, the number of electrons is equal to 2 times the energy level squared. So if we wanted to do a little example, we can look at the third energy level. N equals 3. Total number of electrons is equal to 2 times 3 squared, which that's just equal to 2 times 9, which is equal to 18, which we know is correct because when we counted it, N equals 3 did equal 18. So that helps us figure it out and figure out how many electrons can exist. One last little thing I want to leave you all with is if we take a look at the periodic table, which I'm sure I've got an image of the periodic table somewhere here. Cancel. If we take a look at the periodic table, we can actually look at our periods. 1, 2, 3, 4, 5, 6, 7. Turns out these dictate what the highest energy level that is occupied could be. So if we pick any element like cobalt and we look at its period, period 4, that means that the highest occupied energy level will be 4. So cobalt will go all the way up to N equals 4. We can clarify this just by writing it down and saying that the period, meaning the row of the periodic table, indicates the highest occupied energy level. All right. Well, that's it for this lesson. In our next lesson, we'll start talking about how we can assign electrons to energy levels. But other than that, I hope you had a great day.